We were talking about this protocol BGP, the protocol of internet. Today we are going to see the difference between the two flavors of BGP that we have. BGP is one protocol actually, it's not two protocol, but it has got two different characteristics depending on the neighborship formation. If it forms a neighbor, if a BGP router forms a neighbor with another router within the same autonomous system, it behaves in one way. When it forms neighbor with the router in different autonomous system, it behaves in another way. That's why there are two separate names given to say that these two have got different policies, different behavior. They are not going to behave the same manner. You see, when you have your own child and a neighbor's child, definitely there will be a variation. Whatever the good man you are, there will be definitely one good difference between the own child and the neighbor's child. From heart I am telling, I have more care for my own children, not to the other children. That is the true characteristics of a human being. If someone says, no, I'm seeing equal, then he is not doing the proper justification for his own family. First is family, then only neighbor. You cannot have a same equal with your own child and neighbor's child. Not possible. That's not true. Likewise, when a BGP running device forms a neighbor with another device within the same autonomous system, it's like own family. The neighborship, the policy, the affinity towards it is totally different from the neighborship, the policy that is between two different autonomous system BGP running routers, which we call as eBGP. So, when we say eBGP, it clearly says that I'm forming neighbor with another autonomous system member. So I need to be strict in forming neighbor, allowing and accepting and giving route informations, etc. Whereas when I form a neighbor with an IBGP, my own autonomous system member, I'm liberal, not strict. To explain that behavior, these two different names are given. What is a peer? Peer is equal to the word neighbor. In BGP, people sometimes call it as peer. Peer or neighbor both are same. This doesn't need to be a topic, but they have kept it as a topic because some people don't use the word neighbor. They always like that complicated word. They don't want the simple, easy word. Neighbor is well understood by everyone. So what is a BGP neighbor? A BGP neighbor is a BGP running router that can do successful three-way handshake, after which it can negotiate neighborship and form neighbor. Form, establish neighbor relationship. This is what we call it as BGP neighbor. See, very important is three-way handshake. The reason is it's a TCP protocol. BGP is a TCP protocol. To form neighbor, the first thing is the neighbor should be a reachable neighbor. the neighbor is configured manually. We saw in the previous class the neighbors are configured manually. With that neighbor, the manually configured neighbor, this router will first do three-way handshake. TCP communications always start with three-way handshake. Only when the three-way handshake SYN-ACK, and SYN-ACK, only when this is successful, the further conversation between those two routers will happen. If not, it will try to restart the three-way handshake again and again. So once the successful three-way handshake is done, the other BGP related messages will be shared, and at last it reaches established neighborship. Such established neighbors are called as BGP peers or BGP neighbors. And that neighbor can be between the two routers of same autonomous system, like we see here. Like you see here between router C and router B, or it is between these two routers that belong to two different autonomous systems. Yeah, this is IBGP relationship. See, there is no BGP here. In D, there is no BGP. BGP is there in router B and in router C. These two can form neighbor because there will be a reachability through OSPF or EIGRP or something like that in our autonomous system. So coming to those details later, now what I want to say is your BGP neighbor can be between the routers of same autonomous system, can also be between the routers that are between different autonomous systems. Now comes the detailed explanation for EBGP and IBGP. EBGP stands for external BGP. Here the two routers C and X, these two are not in the same autonomous system. Not in the same autonomous system. Likewise, D and Y are not in the same autonomous system. To form neighbor, we enable BGP, and to form neighbor, the three-way handshake will happen between these two routers, and then they establish neighbor. But when they establish neighbor, they do a strict way. How? Look at this. They don't form neighbor if they are not directly connected. This is very strict. EBGP is forming neighbor with another autonomous system member. Another autonomous system member, not your own autonomous system. So you cannot be very liberal. You cannot be very liberal. It needs to be very strict. Yeah. Why it need to be directly connected? Because they don't belong to same autonomous system. So only when it is directly connected neighbor we'll have that confirmation that we are pairing with the genuine neighbor. Otherwise, there will be a doubt. What if someone is spoofing? C will have a doubt whether it is really a X router or a faked X router. That's why the eBGP neighbors by default need to be directly connected. See, this strictness is not seen in IBGP. You see, between A and C you can form neighbor. A and C belong to same autonomous system. That's why it is IBGP. And you see the second line, the neighbor do not have to be directly connected. Because it is IBGP, the relationship is not established in a strict manner, in a liberal way. A and C are already reachable through SPF or through some IGP protocol. Using the reachability, A and C can do three-way handshake followed by BGP neighborship negotiations. Yeah, so an IBGP neighbor is a neighbor within the same autonomous system, and this neighbor do not have to be directly connected. Now we have three main slides here, important slides here, teaching something very fundamental about BGP. The reason why we are going for BGP is BGP advertises networks. Along with the networks, it advertises attributes. Attributes makes this protocol special. Attributes makes this protocol special. That's why we enable BGP. Now if you see between A and B, we have eBGP, and E and F we have eBGP, and we also have IBGP between B and E. But what we don't have is, on D and C we don't have BGP. On D and C we don't have BGP. Yeah. Now what is the problem in this? I'll explain you the problem by taking you to 2 slides away, and then I'll bring you back here. You see this. Same topology. What you saw in the previous page and what you see here is same. This F is advertising a network. This is connected here. Let's say it is connected to Ethernet 0. That network is advertised. Oh, sorry. No, that's not the story. The network is here. A is advertising the network to B. And B, using B, using the IBGP neighborship, it advertises to E. See, it's a TCP packet, no? B will directly deliver the updates to E. Packet will pass through D. Packet will pass through D, Dandabani D. Packet passes through Dandabani D or Chinnasamy C, but it is not delivered to DRC, it is delivered to Yermala E. So the route will be in the routing table of Yermala, and this Yermala will advertise it to Francis F. So now F is trying to ping. See, the packet is going to the network 10.0.0.0. The packet comes to Yermala. Yermala wants to send the packet to Bhubadi B. So it is sending the packet to Bhubadi. To go to Bhubadi, it goes to Dandabani and say, hey Dandabani, I want to go to 10 network. But Dandabani do not know that Bhubadi knows about 10 network. Because Dandabani do not know about 10 network. Dandabani has got no update. Why? Because Dandabani and Chinnasamy, see, they don't run BGP. Because the BGP updates were not delivered to D and C, they don't have the information about 10 network, so they drop the packet. They will drop the packet, lag of route info. To solve the problem, this is one solution. What is the solution? To Dandabani and Chinnasamy, if the route need to come, you can redistribute. Take from BGP, redistribute to OSPF. Because Dandabani and Chinnasamy, they are running OSPF. You run OSPF on Dandabani and Chinnasamy and Bhubadi and Yermala. As a result, when you redistribute from BGP to OSPF, the network that was given from A is now seen on every router. Now when Francis ping 10 network, Yermala forwards to Dandabani, Dandabani forwards to Bhubadi, Bhubadi forwards to Anand. But the problem is this. Where is the attribute? Because you redistribute from BGP to OSPF, OSPF only metric is cost. So all the attributes that you were having for the network 10 given by BGP is not distributed. Then there is no use of having this protocol BGP. When you redistribute to OSPF, all the attributes will be gone, will vanish. All the BGP unique updates called attributes, they all disappear. So they all will disappear. As a result, you will not have attribute route, you will have only OSPF metric route. That's why here it is said not recommended. You see, redistributing BGP into IGP like OSPF in this example is not recommended. Okay, then what is the solution? Without redistributing, how can you bring the route? You need to run BGP on these two routers as well. Earlier, Dandabani and Chinnasamy were not ready, but now they are ready. If you run BGP, this Bhubadi himself will give to Dandabani. Bhubadi himself can give to Chinnasamy because you are running BGP everywhere. Instead, run IBGP on all routers. So, what I have said so far is, if you wish to distribute the routes via a transit autonomous system, make sure all the routers in the transit autonomous system run BGP. Don't redistribute. This is the transit autonomous system. The middle autonomous system is the transit because it is not a source, not a destination. It is the transit. It's an on the way autonomous system. So, you need to keep in mind that I should not redistribute to an IGP from BGP. If I do that, all the attributes will be lost. Then there is no point of having BGP as a routing protocol. Fine, then what to do? Run BGP on all the routers like this. Like which one? Like the below one, not like the above one. See, what is the difference between this first and second picture? Oh. The first picture is not fully mesh. In the previous slides, we learned that we need to run BGP on all the routers within the autonomous system. In this slide, we see all the routers running BGP, but something more need to be done. What is that? It need to be fully mesh. What does that mean? Every router should be a neighbor with other routers in this autonomous system. For example, if you notice here, it's not full mesh. Bhubadi is not forming neighbor with Elumalai. Bhubadi has got neighbor with Dandabani and Chinnasamy. And Dandabani has got neighbor with Elumalai and Chinnasamy has got neighbor with Elumalai. The problem is Bhubadi is not forming neighbor with Elumalai. As a result, what happens? The advertisement coming from Ambedkar comes to Bhubadi. Bhubadi gives to Dandabani, but Dandabani will not give to Elumalai. See? A route learned via IBGP or never propagated to other IBGP peer. Route learned via IBGP or never propagated to other IBGP. Means Dandapani is learning route from Bhubadi, but Bhubadi won't give it to Yermalai. What is the solution? Make Bhubadi to give directly to Yermalai. That is what the full mesh, you see. Bhubadi is not only neighbor with Dandapani and Chinnasamy. Bhubadi is also neighbor with Yermalai. That is what full mesh. Full mesh is forming neighbor with every router even if it is not directly connected. Forming neighbor with every router. Even with the router that is not connected directly. Only then the route will be given to those not directly connected routers. BGP, to prevent loop, it won't give the route learned from one IBGP to another IBGP. To overcome this limitation, we need to form full mesh. That's the difference between the top picture, which is partial mesh, and this one fully mesh. Is it clear?
Yes, sir.
So, what do we saw? I want to repeat again. In this topology, we see that BGP is not there running on D and C. As a result, the packet will get dropped here. That's the example here. Very clearly saying that packet gets dropped on Chinnasamy or in Dandapani. So to avoid that, you may have a redistribution as a solution, but redistributing BGP into OSPF is not recommended. Why? Two reasons. One, all the attributes will be lost. Secondly, the CPU. When you redistribute from a big heavy protocol to a small protocol OSPF, the CPU will also be consumed a lot. So the solution is run BGP on all the routers in the transit autonomous system. Run BGP on all the routers. When we run BGP, it needs to be full mesh also. The reason is given at the bottom. By default, route learned via IBGP or never propagated to other IBGP peer. So they need to be fully mesh. Right? Don't forget this rule which is there at the bottom. By default, the route learned via IBGP or never propagated to other IBGP. What is the explanation? The route that is coming from Bhubadi to Dandapani or never propagated by the Dandapani to Yermalai. That's the explanation. So, you need to make sure Bhubadi itself will give a copy to Yermalai. Why is this rule? To prevent loop. Right, in detail, you will be learning more and more about this in further classes, in next chapters. This chapter is that's all over. So what do we learn from the beginning? Let's quickly come. There are two flavors of BGP. One is the BGP, which is two router forming neighbor that belong to different autonomous system. Between these, the neighbor need to be directly connected. A strict relationship is seen. IBGP is a neighbor between two routers that are of same autonomous system. They need not to be directly connected. And then we saw this one. This one is talking about a transit autonomous system which need to be fully mesh. Redistribution is not recommended, and all routers should run BGP in the transit. The reason for full mesh is a route learned from one IBGP will not be given to another IBGP. That's why it need to be fully mesh. Is it clear?
Yes, sir.
Next chapter will be about basic configuration of BGP.